Let's look at factoring trinomials. A trinomial usually takes the form ax squared plus bx plus c. Now, this is a trinomial because there's three terms, 1, 2, 3. Those are the number of quantities between the plus or minus signs. Now, it's also called quadratic, meaning the greatest exponent you see is 2. There is an invisible 1 here. This is b times x to the 1 power, but this expression is not linear. Altogether, it's quadratic because the biggest exponent I see is 2. Now, we're first going to factor things that are the simplest case. We're just going to assume that a is equal to 1. So we don't have to explicitly write the 1. It could be invisible. So let's look at an example where what is a quadratic trinomial that takes this form? 1x squared plus 16x to the 1 plus 28. Although I did not explicitly write the 1, assume that it is there. The 1, the leading coefficient a, is invisible in front of the x squared. Likewise, there's an invisible exponent of 1 for the x in the middle term. So every trinomial, unless it's something you can't factor, every quadratic trinomial will factor as a product of binomials. So what is a binomial? Well, it's going to be a variable x and a number. It has two terms. A binomial has two terms. And now there could be a plus sign or a minus in the middle. We're going to figure out what goes there. We need to find out the number and the sign. So looking here, what are some factors of 28 that come to mind? Well, 4 times 7 is the most common. Is this number divisible by 2? Yes, that would give us 14. So I can also express it as 2 times 14, or 1 times itself. So there's 3 different options. There's 3 different pairs of numbers that multiply to give me 28. So which one do I use? Which set of numbers do I use? We use the pair of numbers that would add to the middle term, 16. So positive 2 plus 14 would give me 16. Let's look at another example. Suppose you had x squared minus 13x plus 42. Well, I know that my quadratic trinomial should factor as a product of binomials. Now, here's something we didn't really talk about yet. Now, the sign of my constant, if it's positive, so this is my constant here, a numerical value with no x attached. So if this is positive, I can always multiply a positive times a positive to give me a 42. Or to get this positive constant, I can multiply a negative times a negative. That also gives me a positive. Now, let's satisfy the other condition. These values have to sum in such a way that I get negative 13. So let's look at some factors of 42. Yeah, 6 and 7. Good. Now 6 plus 7 would give me a positive 13, whereas negative 6 minus 7 gives me a negative 13. So this must be my desired combination of signs. It has to be a -6 and a -7. If the given problem was x squared plus 13x plus 42, then my answer would be x plus 6, x plus 7. Let's look at another scenario. How about let's see how the signs for our solution change depending on the signs of the given problem. So in both cases, we had a quadratic trinomial where each term was given as positive. But what if you had x squared minus 2x minus 35? So again, before each term was positive and positive here. Now let's see what happens when we change the signs. I have my product of binomials. I need factors of 35. What comes to mind is 5 and 7. The order doesn't matter. You could have wrote a 5, then a 7. Now what changes? How does my problem change? Well, now the sign of my constant is a minus symbol. I want to multiply two numbers to give -35. So I can multiply a positive by a negative to get -35, or a negative by a positive. They have to sum in such a way that I get a -2. So let's try 7 and 5, 7 and 5. Using my first combination of signs, 7 minus 5 would give me a positive 2x, whereas -7 plus 5 gives me a -2. So this would give me the middle term. The coefficient of x is -2. So my answer should be -7 plus 5. Okay, so let's do another example where we have a negative term and then another negative term, x squared minus 4x minus 60. I write it as two sets of parentheses, two binomials. Factors of 60, I'm thinking 30 times 2, 6, and 10. Now I just got to get my signs right. So again, if this is a negative, my combinations of signs should be plus minus or minus plus. The numbers I'm thinking of using were 10 and 6. Let's insert those between our signs. So the first combination of signs would give a positive 4, whereas the second combination of signs, -10 plus 6, would give -4, which is the middle term of the given problem. So it must be a minus in front of the 10 and a plus in front of the 6. So that's how you can get your signs correct when factoring. So that's two negatives. Now, the signs could alternate in the given problem. So let's look at more examples. So what if you had something along the lines of x squared plus 10x, and then minus 24. So do you see the difference between this problem and the previous ones? It's not x squared plus a number, then plus a number. Then we did examples that were x squared minus a number, minus a number. Now our given expression has alternating signs, but really nothing changes. We'll do the same process. X in parentheses, X in parentheses. Again, our constant is negative. How can I multiply two numbers such that I get a negative 24? How do I get a negative number? I multiply a positive by a negative, or a negative times a positive. So I'm just looking at this sign. Factors of 24, what comes to mind would be 6 and 4. Again, 3 and 8 is another option. But I'm thinking the 6 and the 4 because I want to get that 10 in the middle. Oh, but look what happens here. Would this give me the middle term? Ah, so actually that wouldn't work in this case. So it's true that 6 and 4 would give me 24. And if the signs had to be plus plus or minus minus, this would work. So what other option could we try? 3 and 8 comes to mind. Would 3 and 8 give the correct answer? No. What about 12 and 2? So this is a great problem that a lot of teachers and professors love to give. Because again, look at that. When I see the number 24, do you see how I immediately thought of using options such as 6 and 4? Because normally 6 and 4 can add to give me 10. But also 12 and 2 can add and subtract to give me 10. So do you see how that was ambiguous? So in this case, would these numbers work with this combination of signs? Yes, 12 minus 2 would give positive 10, whereas negative 12 plus 2 gives negative 10. So this must be my combination of signs. I need a positive 12 and a minus 2. Again, let's do that problem. Another problem just came to mind. I said, what if you had something like, yes, what if I changed this problem and made it x squared minus 10x plus 24? What would the answer be? Let's look at my constant. My constant, the sign of my constant tells me the signs of my answer. So this is positive, and you can do this in your head once you get more comfortable. I just like to remind myself, how can I get a positive 24? It has to be a positive times a positive, or a negative times a negative. Also gives me a positive number. So again, you could try inserting between those signs a 12 and a 2. Would that give you a negative 10 though? What about 6 and 4? So 6 and 4 also multiply to give me 24. They add to give me a 10. Or negative 6 minus 4 gives me a negative 10. This is the combination of signs that I want. Again, negative 6 times negative 4 does give positive 24. Negative 6 minus 4 gives the middle term. So if you get comfortable, I love these two examples. When you see them back to back, it's really helpful. If you're comfortable with that, you'll do great. Let's try, let's try other examples when the leading coefficient is a number other than 1, and then we'll call it a day. Let's make it a little harder. I'm going to do something called the A times C method. So let's do a tricky example where the signs alternate in a given problem. So just looking at this problem, I see the constant, the number at the very end. That's a negative number. So I know the signs are going to alternate in my answer. But yeah, look what's different. I actually have a number in front of the x squared. I have a leading coefficient. So what do we do with it? When this happens, you multiply your leading coefficient times your constant. Rewrite this as a 1x squared plus the middle term, 5 times negative 6 is negative 30. So now, see, I didn't know how to factor that given problem, but I can rewrite it with a leading coefficient of 1. So the 5's now gone. It got multiplied into the 6. So this looks like the starting point for our previous problems. Once my leading coefficient is 1, I would factor as I normally do. If my constant's negative, how do I get a negative number? I multiply a positive by a negative, or vice versa. What comes to mind when I think of factors of 30, I think 5 and 6. Would those add and subtract to give me the middle term, 13? No, 5 and 6 isn't going to work. What else comes to mind? 15 and 2. I know those can add or subtract in a way to give me 13. Oh, again, another ambiguous one. 10 and 3 come to mind to give me 13. So which option should we use? 15 and 2. So that would give me positive 13. Whereas this combination of signs, negative 15 plus 2, gives negative 13. X plus 15, x minus 2. Now we're not done because that's the final answer, or the factorization of this polynomial. What if this was your given problem? Well, x plus 15 times x minus 2 would be the final answer. But no, we want to factor the very original given problem. So now what do? I think of it this way. Think of these numbers came from the 30, right? That number 30, well, that's 5 times bigger than it should have been. It was originally a 6, then we multiplied it by 5. So now we want to compensate. We want to go back and compensate for that. If this 30 came to be because it was some number multiplied by 5, well, these numbers are 5 times bigger than they should be. Divide out that 5. So this gives, what's 15 divided by 5? That's 3. Now 2 divided by 5, that would give some decimal. It doesn't give a whole number. None of our numerical values in the given problem, none of them were decimals. So what do? I know it's magic math, but bear with me. You move it in front of the x. And that's your answer. Let's do, again, this is a great ambiguous problem. 15 and 2. When I see those numbers, I think of the middle term 13. But 10 and 3 can also add in a way to give me 13. So what kind of problem would exist where I would use the 10 and the 3? Let's do one more example like that. So if I were to have this problem and have 5x squared minus 7x minus 6, let's see what happens. Multiply leading coefficient times your constant. 5 times negative 6 is negative 30. 2 sets of parentheses. My constant is negative. How can numbers multiply to give me a negative number? Well, a plus times a minus, or a minus times a plus. How can I get a 7? How can I add numbers in a way where I get a 7? Maybe a 10 and a 3. It has to be a negative 7, actually. So it'd have to be a negative 10 and a positive 3. Again, we originally multiplied by 5, so we divide out 5. Giving x minus 2, 5x plus 3. Let's do one more problem. Last problem will take this form. Suppose you had 12x squared plus 17x plus 6. Multiply leading times constant, giving 1x squared plus your middle term. 12 times 6 is 72. Two sets of parentheses. Now, 72 is a large number, but what comes to mind? What are the common factors we always think about? 9 times 8. Let me just double check. This is positive. So the only combination of signs I can have are plus plus or minus minus. Again, which factors do I use? There's many possibilities for 72. Will 9 and 8 work? Yes, 9 plus 8 gives me the middle term. So this should be a positive and a positive. Think of it this way. We multiplied by 2 earlier, or by 12. So now we divide out 12. What happened last time? If these didn't divide to give me a whole number, we would move the denominator in front of the x. We'd make it a coefficient of x. But here we actually have 2 steps we have to do. First, simplify those fractions. Both of these numbers are divisible by 3 at most, right? Giving x plus 3 over 4. At most, both of these numbers are divisible by 4. So the fraction would simplify to being 2 over 3. Now, once you have simplified fractions, denominator becomes coefficient. Oops, I forgot the plus sign. So your final answer will be 4x plus 3 times 3x plus 2. So that was a crash course in factoring. Those were a plethora of examples with different signs in the given problem. So I hope that helps your factoring and your math journey. Have a great day and take care.